One of the most powerful technologies for communication today is fiber optics. So our topic is about fiber optic communication system. Let's begin to the introduction to fiber optic communication system. What is fiber optic communication? The technique of transmitting data from one location to another by transmitting infrared light pulses using optical fiber is known as fiber optic communication. So, optical fiber communication is a method of communication na kung saan yung signal is transmitted in a form of light. The medium of transmission is the optical fiber. Fiber optic communication is mainly used for transmitting voice, video, and telemetry using local area networks. In many telecommunication companies, optical fiber is used for transmitting the signals of telephone, cable TV signals, and internet communication. The data sent can be in the form of audio, video, or telemetry data that is to be sent over long distances or over local area networks. Its great advantage is its immense information carrying capacity. It has a wide bandwidth, whereas hundreds of telephone conversations may be transmitted simultaneously at microwave frequencies. Many thousands of signals can be carried on a light beam through a fiber optic cable. So, no other cable-based data transmission medium offers the bandwidth that fiber does. The volume of data that fiber optic cables transmit per unit time is far greater than copper cables. Why fiber is used? The fiber wire have replaced the copper wire as transmission cable since it has more advantages than the electrical cables. It has large transmission capacity, small losses, easy amplification, low cost, lightweight, no interference, and etc. Large transmission capacity. A single silica fiber can carry hundreds of thousands telephone channels, utilizing only a small part of the theoretical capacity. Small losses. Approximately 0.2 decibel per kilometer. Signal is lost for modern single-mode silica fiber so that many tens of kilometers can be bridged without amplifying the signals. Easy amplification. A large number of channels can be re-amplified in a single fiber amplifier if required for very large transmission distances. Low cost. Due to the huge transmission rate achievable, the cost per transported bit can be extremely low. Lightweight. Compared to electrical cables, fiber optic cables are very lightweight. No interference. Fiber optic cables are immune to problems that arise with electrical cables, such as ground loops or electromagnetic interference. The reasons clearly explain that the fiber optic cables are far better than the actual copper cables, and this is why fiber optic cables are preferred over the conventional transmission mediums. Why light is used instead of electricity? Light or laser light is used for the optical fiber communication because of the reason that the laser light is a single wavelength light source, while the other light signals like sunlight or the bulb light have many wavelengths of light. So as a result, kapag yung sunlight or the bulb light yung ginamit for communication, they would produce a beam which is very less powerful. And on the other hand, the laser having a single beam would result in a more powerful beam as output. So less dispersion, transmitting more number of signals, and consuming less time makes the light a good source of communication. What is dispersion in optical fiber communication? Dispersion can be defined as the transmitting of the light signals once they transmit in a fiber. So this occurrence is mainly because of the light speed that depends on its wavelength as well as propagation mode. When the light travels for long distances, then small differences within speed can be built up, so errors will happen. Similar to attenuation, this dispersion will reduce the distance that signals move within optic fibers. Not like attenuation, it does not decline the signal. However, it blurs. We have three basic elements of a fiber optic communication system. First is the compact light source. The requirements of the sources include power, speed, spectral line width, noise, ruggedness, cost, temperature, and so on. Two components are used as light sources, light-emitting diodes and the laser diodes. Ginagamit yung LED for short distances and low data rate applications due to their low bandwidth and power capabilities. For long distance and high data rate transmission, laser diodes are preferred due to its high power, high speed, and narrower spectral line width characteristics. Next is the low-loss optical fiber. Optical fiber is a cable, which is also known as cylindrical dielectric waveguide, made of low-loss material. Optical fiber also considers the parameters like the environment in which it is operating, the tensile strength, durability, and rigidity. The fiber optic cable is made of high-quality extruded glass like silicone or plastic, and it is flexible. The diameter of the fiber optic cable is in between 0.25 to 0.5 millimeter, which is slightly thicker than a human hair. Depending on the application's wavelength, the material composition of these devices vary. These materials include silicone, germanium, and etc. The third is the photodetector, which is also known as photocell. This is the illustration of light detector. So its purpose is to convert the light signal back to an electrical signal. Two types of photodetectors are mainly used for optical receivers in optical communication system, the PN photodiode and the avalanche photodiode. Basic elements of a fiber optic communication system. We have here the transmitter side, the fiber optic cable, and the receiver side. First, kapag yung information input natin is analog, it is sent to a coder or converter circuit which converts analog signal into digital pulses and pass through a light source transmitter circuit. Kapag yung input naman ay digital, then it is directly sent through the light source transmitter circuit, which converts the signal in a form of light waves. The light waves received from the transmitter circuit to the fiber optic cable is now transmitted from the source location to the destination and received at the receiver side. Now, on the receiver side, si photocell, which is also known as light detector, ang mag-receive ng light waves from optical fiber cable. It converts the light pulses to an electrical signal. The electrical pulses are amplified using amplifier and reshaped back into digital form. Now, if the output source is digital, then the signal is not changed further. And if the output source needs analog signal, then the digital pulses are then converted back to an analog signal using the decoder, using the decoder, where the original voice or video is recovered. To sum up, yung whole process ng pag-transmit ng electrical signal from one point to another by converting it into light and using fiber optic cable as transmission source is what we call the optical fiber communication or the fiber optic communication system. So, fiber optic communication ginagamit sa urban areas, including the best infrastructures wherever it is suitable to arrange communication lines. Yung bandwidth ng fiber optic is very high, including small electromagnetic interference. This kind of communication works with the light signal like a medium of propagation. Optical communication is suitable for point-to-point less distance communication. Fiber optic communication is more dependable. The fewer delays within communication will make the fiber optic cable used in real-time communications. These are mainly used for permanent point-to-point positions which need high bandwidth. These are also mainly used in gigabit local area networks, landlines, internet communications, cable TV networks, and etc. And that would be all for the introduction and basic elements of a fiber optic communication system.
Application of fiber optics cable. Fiber optic communication systems are being used more and more each day. Their primary use is in long-distance telephone systems and cable TV systems. Fiber optic networks also form the core or backbone of the internet. Also, fiber optic cables are no more expensive or complex to install than standard electrical cables, yet their information carrying capacity is many times greater. Fiber optic communication systems are being used in other applications. Like for example, they are being used to interconnect computers and networks within a large building, to carry control signals and airplanes and ships, and last in TV systems because of the wide bandwidth. Fiber optic cables replace conventional coaxial or twisted pair. Figure 19 to 9 list of some of applications in which fiber optic cables are being used. There are the following: the TV studio to transmitter interconnections eliminating a microwave radio link, closed-circuit TV systems used in buildings for security, secure communication systems at military bases, computer networks wide area metro and local area, shipboard communications, aircraft communications controls, interconnections of measuring and monitoring instruments in plants and laboratories, data acquisition and control signal communication in industrial process control systems, nuclear plant instrumentations, college campus communication, utilities such as electric, gas, and so on, station communication, cable TV system replacing coaxial cable, the internet, backhaul for cellular base stations, distributed antenna systems or DAS, connections between servers, routers, and switches in data centers, and lastly, the connection between the cellular base stations and the remote radio head mounted at the antenna.
Benefits of fiber optics. The main benefits of fiber optic cable is their enormous information carrying capability. This capacity is dependent upon the bandwidth of the cable. Bandwidth refers to the range of frequency that a cable will carry. Electric cables such as coaxial cable have a wide bandwidth up to about 750 MHz, but the bandwidth of fiber optic cable is much greater. Data rates is Data rates in excess of 100 GHz have been achieved, and even higher rates have been achieved with multiplexing. So, the main benefits of fiber optic is their enormous information. So, ibig sabihin ng enormous ay may napakalaking kakayahan na magdala ng impormasyon. Fiber optic has many other benefits. And the first one is wider bandwidth. Fiber optic cable have high information carrying capability. So, ang fiber optic cable ay may mas mataas na kakayahan sa pagdadala ng mga impormasyon. Number 2 is the low loss. Fiber optic cables have less signal attenuation over a given distance than a equivalent length of a coaxial cable. So, yung fiber optic ay may mas kaunting signal attenuation. So, ay sa isang particular na distansya kaysa sa katumbas na haba ng isang coaxial cable. And number 3, the lightweight. Glass or plastic cables are much lighter than copper cables and offer benefits when low weight is critical. And halimbawa ay sa eroplano. Ginagamit yung fiber optic sa eroplano. And number 4 is small size. Particular fiber optic cables are much smaller in diameter than electrical cable, thus can be contained in a relatively small space. So, ang practical na fiber optic ay may mas maliit na diameter kaysa sa electrical cable. Kaya mas madali o maaaring ilagay sa mga maliliit na espasyo. So, ganun. And the next one is security. Fiber optic cables cannot be easily tapped as electrical cables. And they do not radiate signals that can be picked up for eavesdropping purposes. There is less need for complex and expensive encryption techniques. So, yung fiber optic ay hindi madaling itap. Di katulad sa mga di kuryenteng kable. At hindi sila naglalabas ng mga signal na maaring kunin para sa mga layunin ng pag-eavesdrop. So, yun. And number 6, interference immunity. Fiber optic cables do not radiate signals as some electrical cables do and cause interference to other cables. They are more immune to picking up interference from other sources. So, yung fiber optic cable na hindi naglalabas ng mga signal tulad ng ginagawa ng ibang mga signal. cables. So yung fiber optics cable ay sila ay immune sa panghimasok ng ibang mga mula sa ibang mga pinagkukuha na ng impormasyon or signal. Okay, number 7, greater safety. Fiber optic cables do not carry electricity. Therefore, there is no shock hazard. They are also insulators and thus not susceptible to lightning strike as electrical cables are, that can be used in corrosive or explosive environments without danger of spark. So yung fiber optics ay hindi nagdadala ng kuryente, and sa mga tuwid ay walang shock hazard, ganun. Hindi katulad sa sa copper wires or cables. Yung fiber optic ay hindi tinatamaan ng mga lightning strikes. Ganun. Disadvantages of fiber optic cable. The number 1 disadvantages of fiber optic cables. The number 1, the high cost. This is the greatest disadvantages of fiber optic. So yung fiber optic cable is napakamahal sa sa merkado, or and number 2, its small size and brittleness make it difficult to work with. Yung fiber optic is maliliit na wires, kaya mahirap talaga. Number 3 is special expensive tools and test instrument are required. So kinakailangan ng mamahaling tools and special tools kasi napakasela ng fiber optics. And number 4, cannot be curved. Fibers can be broken or have transmission losses when wrapped around curves of only a few centimeters radius. So yung fiber optics ay napakadaling masira or maputol or have a transmission losses. Talagang napakasela ng fiber optic. Kailangan ng mas mabusising pamamaraan or tamang pamamaraan. At talagang kailangan ng mas ingat na paggawa, parang ganun. So okay, that's all. Thank you.
Good afternoon po. Unlike other type of transmission media, fiber optic communication uses light pulses instead of electrical pulses to transmit information. Therefore, it uses a different type of cable, which is the fiber optic cables. A fiber optic cable is a thin glass or plastic cable that acts as a light pipe. Fiber cables have a circular cross-section with a diameter of only a fraction of an inch. Some fiber optic cables are the size of a human hair. The image above is an example of a fiber optic cable. As you can see in the inner part of the cable, in these tiny strands is where the light pulses travel. So, how does light signals propagate through a fiber optic cable? If we refer to this figure, we can see that different light beams are entering from different angles. Other beams are being refracted, while other beams are being reflected. Now, if we see on this figure, when light passes from a medium N1 with one index of refraction to another medium N2 with a lower index of refraction, the light that entered will either be reflected or refracted. Usually, at higher angles, a light beam like this, light beam B, will still be refracted but not enough to be reflected back into the core. So, it is lost in the cladding of the fiber. But, below that angle, the light beam will be reflected back to the core and will be transmitted at the end of the fiber cable. Optical fiber uses the optical principle of total internal reflection to capture light transmitted in an optical fiber and confine the light to the core of the fiber. By definition, total internal reflection is a phenomenon in optics by which light experiences complete reflection at an interface between two media. Imagine what happens if the light binds so much that the angle becomes 90 degrees or even larger. In that case, no light will actually be able to travel out of the material it started in, or in other words, it won't be refracted, and it will instead reflected back. When this happens, it's called total internal reflection. So what is critical angle? Critical angle is the greatest angle at which a ray of light traveling in one transparent medium can strike the boundary between that medium and the second of lower refractive index without being totally reflected within the first medium. So basically, critical angle is the smallest possible angle of which light rays are totally reflected. Numerical aperture. It is defined as the sign of the largest angle an incident ray can have for total internal reflectance in the core. In addition, it is the measure of the ability of an optical fiber to collect or confine the incident light ray inside it. It is among the most basic property of optical fiber. The numerical aperture can be calculated with the expression NA is equal to the sine of the critical angle. So here's an example of numerical aperture. The numerical aperture of a fiber optic cable is 0.29. What is the critical angle? We know that the numerical aperture is equal to the sine of the critical angle. But this time, the critical angle is what we're looking for. So if we substitute the value of the numerical aperture, which is 0.29, and get the sine inverse of both sides, we should be getting the critical angle, which is 16.86 degrees.
Fiber optic cable construction. Fiber optic cables come in a variety of sizes, shapes, and types. The simplest cable contains a single strand of fiber. A complex cable is made up of fibers with different layers and other elements. Core is the light transmission area of the fiber, either glass or plastic. The larger the core, the more light that will be transmitted into the fiber. The core of a conventional optical fiber is the part of the fiber that guides the light. It is a cylinder of glass or plastic that runs along the fiber's length. The core is surrounded by a medium with a lower index of refraction, typically a cladding of a different glass or plastic. Cladding is one or more layers of materials of lower refractive index in intimate contact with a core material of higher refractive index. The cladding causes light to be confined to the core of the fiber by total internal reflection at the boundary between the two. The purpose of cladding is to protect a building structure from natural elements like wind and rain, but it can have other benefits such as insulation, noise control, and it can boost the aesthetic appeal of the building. Jacket is the outermost layer of a cable whose primary function is to protect the insulation and conductor core from external physical forces and chemical deterioration. In a sense, the cable jacket is the first line of mechanical defense for a cable by protecting its inner components.
So fiber optics cable. The types of fiber optics cable is one and outer cables, two and inner plenum, three and outer area cable with a messenger, and the outer cables. One and outer cables feature an outer rating and can maintain performance despite harsh element and condition. For example, a moisture, high and low temperature and rating, tearing ion, and tearing affecting signals integrity. But this cable is not designed to be buried underground. Underground cables can be installed when it sits inside a conduit. This added protection allows two cables to sit underground, and when in stand exposure to this element, this cable where what this cable have water blocking filler of polymers gel that stop water infiltration to underground burial cables. The plenum space typically used to house the communication cable for computer and telephone network in a building. However, use of plenum's area for cable storage poses a serious hazard in the event of a fire, because once of the fire reach the plenum space, there are few barriers to contain the smoke and flames. Materials burning in a plenum airspace release smoke and fumes which can travel throughout the whole building, and past burning cables had been a significant culprit in the release of toxic gases during fire. Now, 3 is an outer cable with a messenger. 3. An area solid Cat6 with a messenger is used for application and requires that cable to be outer or between two poles in the area. Area solid Cat6, we call it an outer area cables with a messenger, is made with a LDPE, low density polyethylene low density polyethylene. Polyethylene is a soft, flexible, lightweight plastic materials. Jacket to protect the cables from water and extreme temperature. Arrange a cable called a messenger. Run a parallel to the main cable, giving it strength and stiffness for being run in the air. Four color strip or fair color strip four color strip pairs make is an easy to install and reduce alien crosstalk or reduce an alien crosstalk. This cable is solid by the pole. Solid Cat6 is commonly terminated to an RG45 connector, jack or patch panel. Cat6 is certified for gigabytes internet. So anyone that know the RG45 by using the computer internet or computer internet port. Number 4, an indoor outdoor fiber optics cable called an excellent transmission and mechanical environmental performance. Indoor outdoor fiber optics cable is flexible and has a stress and strain properties. Eh, So what I said on the past three of cables is just the same. Uh, there's no just that called there's no a difference of the cables fiber optics cables. These are cables that are designed to meet both the rigorous environment of the outdoor, but also can be routed indoors, where flames rating requirements also apply. These types of cable eliminates the need for a transition splice to an indoor rated cable when routing an outdoor cables into a building. When routing cables within a building, you will also need to factor in a fire prevention and requirements. Sorry. That's all. Good night.